Dear students, in my last lecture, I had introduced the prassociated natural language. So today we will see how do we actually carry out the prassociation process. So my first step would be to begin with simplified natural language. What do I mean by simplified natural language? I just want to have simple sentences which contains a single verb. There may be an object in it, as we know, and there may be a subject in it. There could be sentences where you don't have object, like the boy is running. We all know, we have studied in English grammar. The boy is running, boy is subject, and there is no object in it. If we say the boy has beaten the animal, then animal becomes object, boy is subject, is beating is the verb. Simple English grammar that we know already. So in my simplified natural language, I have simple sentences which contains only one verb. If there are more than one verbs, then that means it is a compound sentence which is joined by some connectives like and, but, right? So that becomes a compound sentence. So first of all, I'll break all such compound sentences into simple sentences. Let me also say that there could be a case where even subject is not there. For example, if I say go, right? This is a sentence, a complete sentence in itself. It contains just the verb go. It doesn't have any subject. It doesn't have any object, right? So object is optional, and in some very rare cases, even subject is optional. So such verbs we all know are non-transitive verbs where object is not there, right? So that is my first step. Begin with simplified natural language. Now within that simplified natural language, I will look for these protoforms. What are these? I'll explain. X is A to begin with, and then later we will see X is RA. We have seen this construct before. Okay, so this is basically defining X. What is X? When there is a question, what is X? I have the simple answer. X is A, and this R may have so many different forms that I have explained in the previous lecture. It may be veristic, it may be probabilistic, it may be rough set, and so on, so on, so on, right? All those details I've already given. So this is my first protoform. The second protoform is Y is X plus B. I will also give you examples later. Then QAs are Bs. Then Q1 into Q2 A's are B and C's, and Fx is A. So if you see, all these are having the same construct in different forms. For example, over here, Y is X plus B. So it is again X is A form, a variation of it though. Similarly, QAs is X, and R is obviously is, and B's. So this is again X is A form. Then Q1, Q2 A's are B's and C's. So this is Q1 into Q2 A's is X is A form. And then Fx is A, right? What do I mean by Fx? I'll come to that a little later. Again, this is like X is A. So all these are having different variations of X is A form. This is X is A form as such, and these four are its variations. So let us take them one by one. First of all, I'll look for this one, X is A. So prassociation is not the ultimate objective. Basically, prassociation is a prerequisite to mechanization of reasoning and deduction, which is so important in question answering system. In prassociated natural language, a concept which plays a key role in deduction is that of protoform. As I've given 5 protoforms. There may be more protoforms. These are just to begin with. Protoform, which is an abbreviation of prototypical form. So protoform in short is prototypical form. A protoform of a proposition or a collection of propositions is an abstracted summary. So if we put all these protoforms together, it becomes an abstracted summary. So summarization, reasoning, deduction, they all become so very easy if we are able to prassociate a natural language. So a natural language, generalized constraint language, and what is done is prassociation, which is taken to be a kind of translation. So this is the precession of P, which is the generalized constraint. And let us take an example. Karen lives in a small city near San Francisco. How can I put it in the proto form? I can say X location residence Carol. This will be X. This all part will be X. Location of residence of Carol. And this all becomes A. So X is A form. So that is why I'm saying X is A or X is R, whatever. Near city, which is also a small city and a small city, right? So this is how I'll translate it. So let us see how do I do. First of all, I'll have to do the part of speech tagging. We all know parts of speeches. Basically, we are taught with 8 parts of speeches, and then if we go to its different forms and variations, they become a pretty large number, like 36. I can see 36 part of a speech tag sets. And there is a standard Stanford tagger. It takes a sentence or a file and tags according to Penn Tree Bank tag set, 36 part of speech tag sets, and 12 other tags for punctuation and special symbols. For example, if I give to this Stanford tagger, Stanford POS tagger, if I give this input, airway is ideal for the home or small office, what it will return is, it will tag each and every word of it with the part of a speech tag set. For example, airway, it says NNP, proper noun, is, this is continuous verb. Ideal, it is again giving proper noun. Why? Because this I you have written in capital. Okay, it may have been an unintentional error or a typographical error, but then part of speech tagger will identify this as a proper noun. For, the, this is determiner, then home, common noun, or, which is conjunction, small, adjective, office, again a common noun, right? So it takes a sentence, a simple sentence, and then returns with every word of that sentence tagged according to part of a speech tagger tag set, Penn Tree Bank tag set. So NNP stands for proper noun, VBZ stands for third form, ing form, then in is preposition, DT is determiner, noun, coordinating conjunction, adjective, sentence, or final punctuation. So now, after having done the part of speech tagging, what I can do, I can write a class in Java, or any such, where I can write a class, integer field for error when no verb at all. For subject, verb, and object. And these fields may correspondingly be blank if the object is missing, or if even the subject is missing. If the verb is missing, it will give an error -1. So sentence phrase, extract phrase, this is a method which will operate on this class. This extracts the subject phrase, verb phrase, and the object phrase from a given simple sentence. Simple is important. It should have only one verb in the sentence, which has already been tagged in accordance with the Penn Tree Bank tag set. So simple sentence, tag it and give it to this method, extract phrase method. Now again, what will happen? Verb phrase between the first and last occurrence of VB. It may also include models like will, if there are such any. Subject phrase all before the verb phrase, object phrase if any, all after the verb phrase. For example, if I give this, which I had tagged already, the subject phrase is airway. Why? Because this is the first occurrence of VB and this is the last occurrence of VB. Okay, and there are no models in it. So my, first of all, it will pick out the verb phrase, allows linking. This is the verb phrase. All before it is subject, all after is the object, right? This is the subject and this is the object, right? So starting from VB and any variation, and all what ends with VB and any variation, along with the models like will, shall, should, so on, so on. So sentence phrase is form. I'm using another method, is form. This checks if the given tagged sentence is a simple X is A form. It checks for all the variations of is, covering all modalities and tenses of the to be verb. We all have been taught to be is the general form of the is verb. So verb phrase should be entirely equal to any of the following forms of is. What could be different forms of is? A huge list. Is, was, were, are, am, shall be. They're all the variations of is, right? Must possibly be, should likely to be, could likely be, most, must mostly be, so on. The list continues, and I may have further additions in it, ought, often to be, and so on. So they're all the variations of is that we have listed. So any such variation found, it will say that it is X is a form. So for example, the cost of calls to Spain will be about 40 pence per minute. So will be taken as the one of the variations of is. First of all, tagging. Once tagging is done, identification of the verb, which is will be, because we see here will be, models and VB form, right? So all what is there, this will be my verb. All before it is subject, all after is it object. So now it becomes very easy. Since will be is one of the forms of is, so we will say that this is an X is a form, with X being the cost of calls to Spain, and this will be replaced by the standard is, and about 40 pence per minute is X is a. So when the question comes, what is the cost of calls to Spain? What is X? I know X is a. The cost of calls to Spain is about 40 pence per minute. Airway allows linking a number of telephones. If I use this sentence and I give it to is form after tagging, and then my verb phrase is allows linking, which is not a variation of S, of is, right? So this may be the subject, this may be the object, but since the verb is not one of the forms of is, so it will return not an X is a form. So my is phrase method will, is form method will return not an X is a form. So this is about X is a form. Now let us come to Y is X plus B, which is essentially a variation of X is a. This is X, this is A, right? So what does it mean? The cost of calls to Spain is about 40 pence per minute. There's another proposition which says the cost of calls to Germany is a little more than the cost of calls to Spain. So my Y is the cost of calls to Germany is standard. This is X, the cost of calls to Spain, and a little more than is this B, and a little more than is this B. So I can put it in the form the cost of calls to Germany is the cost of calls to Spain plus a little more. So now this becomes Y is X plus B form, which is, as I'm repeating again, at the cost of repetition, I'm saying, which is nothing but a form of X is A, but a more convenient form, in fact. Now, what will be what can be the question answering in this case? If somebody asks what is the cost of calls to Germany and the proposition says cost of calls to Spain is about 40 pence per minute, so my answer after deduction would be, I can apply deduction now. I can say the cost of calls to Germany is 40 pence per minute plus a little more. So now if you give me the membership function, I can say that the cost of calls to Germany is like 45 pence per minute, 43 pence per minute, 50 pence per, depends on what kind of membership function I present to my fuzzy logic deducer, right? So, but in order to do Y is X plus B form, I have to write the match phrase class, which is the float field for the similarity value between two given phrases, two string fields for the match phrase, and the extra part in the larger of the two phrases. For the X's and A's of every X is A match phrase, this is the method compute similarity between AI and XJ, right? Exact match, I'm taking one. Exact match regardless of upper lower case is 0.95. The arbitrary values that I'm assigning. Matches only near the beginning of the phrase is 0.85, near the end is 0.8. Exact match of the stemmed values 0.65. Suppose it says the costing of calls to Spain in one case and the cost of calls to Germany in the other case. So I'll have to see that this is not an exact match, but after stemming, it will come out to be a match. Matches of stemmed values only near the beginning of the phrases is 0.55. Stemmed values near the beginning. Matches of stemmed values near the end of the phrase is 0.5. Or obviously for stemming, I can use either Porter stemming algorithm, and stemming should include stop words removal too. There are stop words, they must be removed. But I'll have to have different stop words list. Otherwise, if you use the standard list, is will also be eradicated, will also be eradicated. So I'm not, I want to retain them because then only my X is a form or variation of it can be deducted, can be detected. Now, synonym matches similarity is 0.45 for you. By using WordNet, I can use synonym. For example, in one case, it says the cost of calls to Spain. The other case, it says the price of calls to Spain. So price and cost are synonymous. That you can find out from WordNet and give a similarity value of 0.45. Matches are just a few words there and there, 0.4 and 0 similarity otherwise. So my just let me quickly take you back. Yeah, compute similarity. It will return float field for the similarity value between two given phrases, and then the two string fields, which one is matching, so that has to be common, x has to be common, and what is the extra part, right? So it should return what is common. So common is the cost of calls to Spain, and the extra part is a little more than the cost of calls to Spain, the cost of calls to Spain. So perfect match, or it should rather be regardless of the case, because T is capital here. So it should return 0.95 as the float value. It should return the cost of calls to Spain, which is common to both, and a little more than, which is extra. So let us see the third variation now. QAs are B's forms. Where it is used, it is again is a variation of R is a variation of is. So this is basically X and this is basically Y, or X is A, whatever. If you're calling it X is A, so this is X, this is A. So look in A, not in B for any of the following. This is quantity, some, somewhat, few, none, many, almost, a little bit, about, most, all, a lot, numbers. Why I'm not seeing it in B? Because then it will be more likely the X is RA form. If it is in B, then it becomes this small r rather than this big Q, this capital Q. So also look in A for any numbers in either digits or words or a combination of both. I'll give you the example, then it will become more clear. So numbers could be 1, 2, 3, 4 up till 19, and then 20, 30, 40, because after that it will be 21, 22, 23 variations of it. Then it will go all the way till 90, and then 100, and then 1000, and then million, billion, hundreds, thousands, millions, billions, trillions. The list may go on. So now let us take the example. If suppose the input is here, most Swedes are tall, right? What should be the output? Q A's are B's, where Q is most. Here Swedes is A, tall is B's. For example, if I give a total of 4.3 billion, 1,200,044 humans is the population of that country. Just for the heck of it, I've taken an example. So in this case, my Q is a total of, my Q is this thing. 43 billion 1,200,044 is my Q, which tells about the quantity. A total of humans is like A, and R is obviously a variation of is, and the population of that country is like B. Okay, so this will be, so QAs, QAs are B's. Now the one Q1 into Q2 A's are B's and C's form. Let us take an example first and then we'll come back to it. P1, most balls are large. P2, many large balls are heavy. Now the question comes, how many balls are heavy? So we see that most into many balls are large and heavy. So if the question is how many balls are large and heavy, so I'll have to compute using words, using computing with words, most into many. Give me the membership function of most, give me the membership function of many. I'll do fuzzy multiplication and I can give you the answer depending on what kind of membership function you have provided for most and many. So QAs and into Q2 A's are B's and C's form is essentially a variation of Q A's R B's, right? Which again is a variation of X is A, right? So how do you do that? You have Q1 A's are B's, Q2 A and B are C's. You will have to stop it. You will have to locate it there. So I'll have to make use of compute similarity, the method compute similarity, and I'll have to find out their length, and then match phrase M2 is compute similarity M1 of its first part and the second part. Then I can print if it is not equal to 0, which means it is not completely dissimilar, then we print Qj into Qk, Aj's are Bj and Bk's, right? So I'll use the same methods, the same class, match phrase and compute similarity method in order to detect Q1 into Q2, A's and A's are B and C's, right? Now the last protoform or the last variation of X is A form, Fx is A. When I say his son is quick, actually I'm talking about the speed of his son is quick. Although the word speed is not mentioned, but I mean to say that the speed of his, if the question comes, who is his son or what is his son, you cannot give the answer, his son is quick. Quick is about the speed of his son and not about son as such. Okay. So I do the part of speech tagging, which gives me his son as the subject phrase, verb phrase as is, and quick as the object phrase. So how do I detect that this is fx is a form? For that, I'll have to talk about the concept depending on the words that occur. Crawl, fast, quick, rapid, slow, lightning, fast, talks about speed. Newborn, newly born, newborn, in fact, infant, young, middle age, so on, so on. Mature talks about age. Cheap, fairly expensive, expensive, moderate, fee, this talks about cost. And this list may go on. Everywhere this list may go on. I've taken some exemplary values of the concept. Likewise, dimension, angstrom, micron, so on, weight, heavy, featherweight, size, small, large, big, temperature, shade, volume of sound, scent, texture, health, quantity, time, taste, appearance, and you can go on adding it this way, you can go on adding it this way, right? So any of those concepts, for every x is a, if a contains any of the listed values, then actually f is the concept corresponding to that value. If any of those values occur, for example, healthy occurs, so that means I'm talking about health. If many occurs, so I'm talking about quantity of it, right? However, exclude those cases where the concept value is followed by a noun, because in that case it will more be an adjective rather than the value, rather than the adverb, right? Airway, for example, airway, so on, so on, so on. I do the part of speech tagging. Undesirable output, probably size of airway is small. I don't want to keep this output, so this is an indesirable or an incorrect output. Okay, so I can never assure 100% accuracy in any natural language processing task, leave alone processor in natural language. So there may be some outliers anyway, but we have to minimize the outliers. That is our goal. Now coming to their addition of R in all in all five of them, looks in A, X and is form for any of the following: probably, usually, partially, possibly, mostly, likely. So that will become small r. For Y is Rx plus B, looks for any of the above in Y, X, B and is form. For Fx is Ra, look for any of the above in X, A and is form. The heart of airway example, the heart of airway network is possibly the controller. When you tag it, you find out the subject phrase, verb phrase, object phrase. It will not be listed as X is A form. It is X is RA form, because possibly will be small r. The heart of airway network will be X and the controller will be A. Okay, because this possibly has been picked out from here. So that will be my small r. Likewise, Y is Rx plus B. The cost of cost to Germany, the same thing, input, tagging, subject, verb and object phrases. then I can identify that since probably occurs in the object, so I'll pull that out as the small a r, and the cost of course to Germany is, this is y, the cost of course to Spain is x, a little more than is b, and similarity value is 0.7 because there must be some the cost of course to Spain, the cost of course to Spain, because this d occurs, right? So the cost of cost to Spain, that is why similarity value is coming out to be 0.7, and obviously some casing etc. Also 0.7 case is the similarity. Fx is Ra example, his son will probably be quick. Okay, so this quick tells me that I'm talking about this quick tells me that I'm talking about the speed. So probably is taken as small r, and probably is a small r, speed of his son, because I'm talking about quick, so speed of his son, although speed doesn't occur here, but still I'm drawing from the table, the concept table that I've given earlier. So speed of his son is quick. So his son is quick means his son is probably quick. So this means that I'm taking, so a lot of things are happening over here. You see, will be is taken as an is form in the first place. Probably is taken as a small r. Quick is telling me that I'm talking about the speed of his son. So this is fx is ra form, where this r is probably, where f is speed, x is his son, and a is quick. So if this is not the end of it. I have said in my previous lecture that this is not a definitive theory as such. This is more of a beginning rather than the end to the pre-associated natural language. So if I can sum up a concept which plays a pivotal role in PNL is that of a protoform. The 5 protoforms or the variations of them that I've seen. A concept which touches upon 2 fundamental facets of human cognition, the ability to summarize and the ability to abstract. The concept of a protoform serves 3 basic functions: organization of knowledge, deduction, and definition. So organization knowledge is better organized. I can do deductions. Like I can deduce that I'm talking about the speed of his son. I can deduce that cost of calls to Germany is the cost of calls to Spain plus a little more. Those kind of deductions, or 40 pence plus a little more, that kind of deduction. And definition. What is X? X is A, right? So it talks about definition also. Now, by providing a system for pre-association of natural languages, PNL opens the door to a wide-ranging enlargement of the role of natural languages in scientific theories, especially those theories in which human judgment, perceptions, and emotions play important roles. Because I can have fuzzy words there, probably, possibly, approximately, those kinds of words, and which are so very natural in the human speech. We all use all those words so very frequently, right? Now, what could be the future directions? I can likewise work on adjectives and adverbs. So this I'm leaving for you to carry out future research, because this will be the last lecture. So this will be the future directions that you can explore later. Fast, high, beautiful, clever. Adjective, they are mostly imprecise. Some adjective adverbs are just not quantifiable. Beautiful and clever, they're not quantifiable. High, fast, they can be quantified. Fast maybe in terms of kilometers per hour, light years, and so on. No, fast is not light year. Light year is a distance, right? High, you can say how many kilometers, how many meters, and so on. Zadeh has a special, Professor Lotfi Zadeh has a special term for them. They are called V precise, which cannot be quantifiable, or V precise. Leave them alone. Suppose let us work on the rest, like fast, high, etc., which are quantifiable in theory, namely M precise. They are mathematically well defined. So they are mathematically precise, right? In 3 forms, X was running fast, X was running faster. Okay, fast, faster, fastest. Good, better, best. Bad, worse, worst. So if I give you the membership function of fast, what will be the membership function of membership value of faster, what will be the membership value of fastest, and so on. So those three forms is another direction that I can. The first direction, future direction, is adjectives and adverbs, because they are actually defining the noun or the verb or the adjective, because adverb is something which defines either the verb or the adjective itself. If I say he is very beautiful, okay, so very becomes adverb here. Beautiful is adjective and very is adverb because it further describes the adjective. The second could be the three forms of the or three forms: fast, faster, fastest. Okay, good, better, best, and so on. Now, subject dependence. If I say clever X did the job satisfactorily and clever Y did the job satisfactorily, where X is a human being, Y is monkey. So their cleverness should differ. They're not equal. In the above two, level of satisfaction varies. Now X is human being was running fast, Y animal was running fast, Z machine is running fast. Again, machine could be a car or machine could be a computer. Okay. So what do you mean by fast in all these cases? For a human being, running fast could be like 10-15 kilometers per hour. Animal running fast could be like 300 kilometers per hour. Just as cheetah runs or any other or some birds, they fly at such a high speed. Machine, you can have starting from a bicycle to a motorbike to a car to the airplanes to the aircrafts, and then again computers. You know, how fast is your cell phone, how fast is your laptop, how fast is a supercomputer, and so on. So combining with generalized consonant language, adjective, clever X is probably doing the job more satisfactorily, right? So more satisfactorily, this becomes another, qualifier on top of probably. Adverb, X is was probably running faster. Again, probably and faster. So you have combinations of them. More complex forms, a more clever X probably did the job properly, combining adjectives, adverbs, and GCL into one. A more clever X, you see, probably, your R, small r, did the job properly. What is properly, right? Then generalized forms, I can say adjective X is ry, adverb X is r, verb followed by adverb. Complex forms, adjective X is r, verb and adverb. So on this side it is describing the adverb, and on this side this is describing the noun X. Recursion of adverbs. An adverb describes a verb, an adjective, or another adverb. That is the definition of adverb. Same adverb repeated many times. He's running really fast. He's running really, really fast, or very, very fast. Different adverbs. X is flying really very high. Y is flying really much, much higher than the rest. So these are all, so much scope of using precisiated natural language. These are all unprecisiated forms. So I really much, much higher. Okay. So you need to precisiate them. Same adverbs repeated. So what should be its syntax? Adjective, X is R, verb, adverb, n times. Different adverbs repeated. Adjective X is our verb, adverb 1, adverb 2, so on, adverb n, and some of them may be powers. Combination, adverb, adjective, X is R. Adverb to the power n1, adverb to the power n2, adverb to the power nm, and so on. Right? Okay, so we will stop here and that will mark the end of the course. So all the best.